Hi, I'm Aniza Said, and today we are going to be learning more about Math 9 pre-IB polynomials and factoring a difference of squares. Part A will be the warm-up. Now we are going to do two multiplication questions. The first one is m plus 2 times m minus 2. First, we need to multiply m by m and m by negative 2. This will give us an answer of m squared minus 2m. Then, we need to multiply 2 by m and 2 by negative 2. This will give us an answer of 2m minus 4. Both our answers combined will give us m squared minus 2m plus 2m minus 4. This is not a final answer, but to get the final answer, we need to add the like terms, which are negative 2m and 2m. Both of these answers are the exact opposite of each other, so we can cross cancel and get our final answer of m squared minus 4. Next, we need to do our second question, 3m minus 2b times 3m plus 2b. First, we need to multiply 3m by 3m and 3m by 2b. This will give us an answer of 9m squared plus 6mb. Then we need to multiply negative 2b by 3m and negative 2b by 2b. This will give us an answer of negative 4b squared minus 6mb. Both of our answers combined will give us 9m squared plus 6mb minus 6mb minus 4b squared. To get the final answer, we need to add the like terms. The like terms are 6mb and negative 6mb. Both of these are the opposite of each other, so we can cross cancel to get our answer of 9m squared minus 4b squared. Now, for our next warm-up, we are going to write an expression for this set of tiles, and then we're going to simplify and factor. First, each black tile is positive, each white tile is negative, and each big square is x squared, each rectangle is x, and each small square is 1. Now, let's start with the top over here and work with these tiles underneath. Now, with the legend, we know that this big square is x squared, and these two make negative 2x. Firstly, we need to know what's a factor for both x squared and negative 2x, which is x. Now that we have x, we need to know what we'll multiply by x to get these tiles. X squared divided by x equals 2x. And we have one factor for 2x over here, so we could solve the top part of these tiles. X divided by x is 1, and that works for both of these tiles. Now we need to work with these negative tiles over here. A negative times a positive is a negative, so we know the missing tiles are negative. Now, what do we need to multiply by x to get negative 1? Negative 1, which works for both of these. Now that we've completed the tiles and got x plus 2 times x minus 2. Now, we need to get our final answer, and we need to do that by cross-canceling. To cross-cancel, we need to find and add the like terms. These four over here are the same shape, just different colors, meaning they're the opposite of each other, so we can cross-cancel. Now, what's left? X squared and negative 4, and that's our answer. We are now on to part B, examples for one-step factor. Now, we are going to factor these four binomials, but in order to factor a binomial, there should be two rules that apply. There should be two perfect squares, and one of the terms must be negative. So, these rules apply to x squared minus 9, so we can continue. When factoring, place two brackets. Then, we can place the square root of x squared in the beginning of both brackets, which is x. Now we place the square root of negative 9 at the end of both brackets, which is 3, but since it's a negative number, we'll place a negative root in one and a positive in the other. And that's our answer. Now, for m squared minus b squared, we need to look at the rules and see if they apply. They do. We have two perfect squares and a negative term. The first step is usually the same every time, and that is placing the brackets. Now, we could put the square root of m squared in the beginning of both brackets, which is m. Finally, we place the square root of negative b after the m, but since it's a negative, we put a positive root in one and a negative in the other. And that's our answer. Now, for these next two, it may be a bit different, but I want you to try them. So pause the video right now, and after you unpause, I will show you the way to do it. Okay, I'm assuming you've unpaused and are done with these, so now I'll show you how to do them. First things first, we need to check if the rules apply for 4m squared minus 9b squared, and they do, so we can start by placing the brackets. Now, we can place the square root of 4m squared, which is 2m. Now, I need to place the square root of 9b squared after the 2m, which is 3b, but since it's a negative, we put a positive in one and a negative in each bracket. And that's our answer. Now, our final one, 25f squared minus 36n squared, has bigger numbers in it, but it still works the same. First, we need to check if the rules still apply, and they do, so we can continue with placing the brackets. The square root of 25f squared is 5f, so that's what we'll place first. And the square root of negative 36n squared is 6n, but we place a positive in one bracket and a negative in the other. And that's our final answer for this part. Next is our final part, part C, multi-step factoring. We are going to start with 3k cubed minus 12kt squared. These are going to be a bit different than what we did before, but what stays the same is the set of rules. Firstly, there should be at least two perfect squares. We could take k squared out of k cubed, and we could take 4 out of 12 and t squared. Secondly, there should be at least one negative term, which in this case is negative 12kt squared. Now, we need to take everything that isn't a perfect square and put them before the brackets. I pointed out there being a perfect square in k cubed, meaning there's one k left, and there's also an extra k from over here too. And there's also 3, which is from both terms, and that's what we'll put in front. Now, for the brackets, we need to put in the perfect squares. If you do not remember what I circled in the beginning, you can quickly divide each term by 3k, which will lead us to get k squared minus 4t squared. However, this isn't our final answer. The reason is because we need to factor completely, and if you look at the rules, we can factor what's in the brackets. There are two perfect squares and a negative term, and since we're only working what's in the brackets, we could just leave 3k alone and outside the brackets. Now, this is where it gets similar to what we did before in the previous parts. First, we have the brackets with the square root of k squared in, which is k. And then we have the square root of negative 4t squared, and that's the answer. This next one is easier but still quite different. I want you to pause this video right now and try solving it. Okay, so now I'm assuming you've unpaused, so now I'm going to show you how to do it. First, check the rules. They apply, so we can continue with placing the brackets and putting in the square root of 81m to the 4th power in these brackets. Then, right after that, we'll place the square root of negative 16. But then again, we're not done. Check the rules. But only one of these brackets apply to all of these rules. And that's the second one, because the first one doesn't have a negative term. So we can do what we did with the 3k and leave the first set of brackets alone. Now we could place the square root of 9m squared in both brackets, which is 3m. Then we could place the square root of -4 after 3m. And that's our final answer for this lesson. That's all.